Have you ever struggled through a math class wondering who on earth came up with all these rules about points, lines, and shapes? Well, a lot of it traces back to one incredible mind from ancient Greece, a man named Euclid. Today, we're journeying back over 2,000 years to uncover the story of the man known as the father of geometry. So, who was Euclid? Honestly, we don't know a ton about his personal life. He was a bit of a mystery. Historians believe he lived around 300 BC in Alexandria, Egypt, which was a bustling hub of knowledge and learning at the time. It was home to the legendary Library of Alexandria, the greatest collection of scholarly works in the ancient world. It was in this vibrant intellectual environment that Euclid did his most important work. He wasn't just a mathematician, he was a teacher, gathering students and sharing his profound insights into the world of numbers and figures. But what truly cemented his legacy wasn't just his teaching, but the book he wrote. This book is called The Elements. And when I say it's one of the most important books ever written, that's not an exaggeration. For over 2 millennia, The Elements was the primary textbook for teaching mathematics. Imagine that. A single book shaping the minds of countless generations, from ancient Roman scholars to Isaac Newton and even Albert Einstein. It's been printed in more editions than any other book except for the Bible. So, what made it so special? The Elements wasn't just a random collection of math facts. It was a masterpiece of logic and structure. Euclid started with the very basics, things that seemed so obvious they couldn't be proven, but had to be accepted as true. He called them postulates and axioms. For example, one of his postulates is that you can draw a straight line between any 2 points. Simple, right? Another is that all right angles are equal. These were his foundational building blocks. From just a handful of these simple starting points, Euclid built the entire system of geometry, step by logical step. His method was revolutionary. He would state a proposition, a mathematical statement like the Pythagorean theorem, and then prove it using only his initial axioms and previously proven propositions. Every single step had to be justified. This rigorous, logical deductive method became the gold standard for mathematics. He wasn't necessarily the first person to discover every single theorem in The Elements, but he was the genius who organized them into a single, coherent, and logical framework. He created a system where knowledge could be built securely upon a foundation of truth. The Elements consists of 13 books, or chapters. The first few deal with plane geometry, the study of flat shapes like triangles, squares, and circles. This is where you'll find proofs for things you might remember from school, like the sum of the angles in a triangle is 180 degrees. He explored concepts like parallel lines, congruence, and similarity with incredible precision. For instance, his famous 5th postulate, the parallel postulate, puzzled mathematicians for centuries, and eventually led to the development of non-Euclidean geometries, which are essential for understanding things like Einstein's theory of relativity. But Euclid didn't stop at flat, 2-dimensional shapes. He ventured into the 3rd dimension, exploring solid geometry in the later books of The Elements. He delved into the properties of spheres, cones, and cylinders. He also laid the groundwork for number theory, exploring concepts like prime numbers and proving that there are infinitely many of them. Think about that for a moment. Over 2,000 years ago, Euclid proved that you can never, ever find the last prime number. It's a discovery that remains fundamental to mathematics and computer science today. There's a famous story about Euclid that perfectly captures his philosophy. Apparently, a king, Ptolemy I, asked Euclid if there was a shorter, easier way to learn geometry than by studying the elements. Euclid's reported reply was, "There is no royal road to geometry. In other words, there are no shortcuts. To truly understand, you have to follow the logical path step by step." This highlights his commitment to rigor and his belief that understanding is earned through diligent effort, not handed to you. The influence of Euclid's work is almost impossible to overstate. His logical approach didn't just shape mathematics, it shaped all of Western thought. The idea of starting with basic assumptions and building a complex system of knowledge through logical deduction became a model for philosophy, science, and even law. When the American Declaration of Independence states, "We hold these truths to be self-evident," it's echoing Euclid's idea of axioms, fundamental truths upon which a new system of government could be built. Even today, in our age of supercomputers and advanced AI, the principles Euclid laid out are still at the core of so much of our world. Architects and engineers use Euclidean geometry to design stable buildings and bridges. Computer graphics and video game designers use it to create the realistic 3D worlds we love to explore. GPS systems rely on its principles to pinpoint your location on the globe. Euclid's ghost is in the machine, in the blueprint, and in the very structure of our logical thinking. So the next time you see a perfect circle, a towering skyscraper, or even just a simple triangle, take a moment to think of Euclid. He was more than just a mathematician. He was an architect of reason. He taught the world how to think logically, how to build complex ideas from simple truths, and how to find order and beauty in the abstract world of shapes and numbers. He showed us that with a few simple rules and a lot of careful thought, we can unlock the secrets of the universe. Thank you so much for joining me on this journey back in time. If you enjoyed learning about the incredible legacy of Euclid, please hit that like button and subscribe for more stories about the brilliant minds who shaped our world. Let me know in the comments which historical figure you'd like to learn about next. Until then, stay curious.